Hello, and welcome to the third challenge problem set. Right now, we're going to go through problem number 1, and I'm going to leave you number 2 to do on your own. Yeah, so number 1 is just a really complicated vector problem. I can read it aloud to you right now. It says a Coast Guard ship is located 35 kilometers away from a checkpoint in a direction 42 degrees north of west. A distressed sailboat is located in still water 20 kilometers from the same checkpoint in the direction of 36 degrees south of east, and it's about to sink. So your instructions are to draw a diagram indicating the position of both ships, in what direction and how far must the Coast Guard ship travel to reach the sailboat. So I don't have a digital copy of this to show you right now, but I will draw the diagram. So here's what it's going to look like. Just roughly, let's just say we have, let's use, I gotta go over here and pick this. Okay, so let's say we have a checkpoint right here in the middle. Right here. That's a checkpoint. And I'm going to make the north, south, east, and southeast, and west axis from this. Whoa, that's really off. Let's say that this is the checkpoint. Right. So that's north, east, south, and west. And that's a funky line right there. Okay, so first, we've got the sailboat. The sailboat from this checkpoint right here, which I guess we can call our origin right now. The sailboat is 20 kilometers and 36 degrees. This is about like that. So that's like 36 degrees south of east. And here's a little sailboat. It's a tiny little sailboat. There it is. And then we got the Coast Guard ship. The Coast Guard ship is up over here. And it's like this. It's like 42 degrees north of west. So here we go. 42 degrees. 42 degrees. And here's the Coast Guard ship. It's a big ship. Okay. So that's our Coast Guard. CG is Coast Guard. And this is our little sailboat. I'll call that SB. Sailboat. Right. So what do we have to do here? Oh, right. And I also need to tell you the distance from this checkpoint in the middle here. That's the other piece of information that's given. So the sailboat is 20 kilometers away. And this Coast Guard is, 35 kilometers away. So we got everything set up. The question is, I think, how far away is the Coast Guard from the sailboat? So that's going to be a straight line. So let me give you a straight line right here. I'm going to use turquoise to go from the Coast Guard to the sailboat. Here it is. From right there, it's going to be a straight line. And this is going to be straight, I swear. Almost straight to that right there. It's not this line right here, because this is 42 degrees and that's 36 degrees below that. They're not the same angle from the x-axis, so it's not going to be a straight line in between here and here. The blue, the turquoise, represents the line between the Coast Guard and the sailboat. And I want to know, what's that distance? So here's how we're going to break this down. I'll tell you the strategy, and then I'm going to draw a little diagram right next to this, so it's a little bit easier to see. So the strategy is, I'm going to break down this. I'm going to treat it like a vector. I'm going to break it down into its x components and its y components. And I'm going to break this down into its x components and its y components. And then I'm going to take both of these components and I'm going to add them together to make one big triangle where this blue line, this turquoise line, is the hypotenuse. And when I do that, I'm going to find the distance of that hypotenuse. And I'm also going to find this angle from, I guess I'm going to make it from south, from the north and south axis, the angle from the Coast Guard ship to this sailboat. Okay, so I just described it in words. Now I'm going to try to draw a little tiny diagram to show what I'm talking about. I'm just going to redraw this. So I'm going to do the blue line again over here. this is that hypotenuse that I just drew right here. So that's the distance that I want to find. I want to find that blue line. And I'm going to break down the vectors like this. So I'm going to use tangerine for the x right here. So here's the x component of the sailboat from the checkpoint. I'm going to draw that in a straight line. So I want to find that. And right here, the x component of the Coast Guard, I'm just going to do a dotted line. That's kind of dotted. A dotted line. So this is our x component of the Coast Guard, and this is our x component of this distance right here, this vector right here, the x component of the sailboat. Okay. Now I'm going to argue right now that this x and that x will equal a straight line that looks like this. So that's the x of the sailboat. And this dotted line right here is the x of the Coast Guard. That's x of the Coast Guard. All right, and now I'm going to do what color? I'm going to use red. Not red. This is a big decision. I'm going to use lavender. Lavender is going to be my y component. So lavender is my y component for this vector right here. So I could write it right here, or I could write it right over here. So I'm going to do it right here. This is my y component of the sailboat. Y of the SB. So that is going to be about this distance right here. Whoa, that should be straight. That distance right there, that's my y component of the sailboat. And this dotted line coming down, which is supposed to be a straight line again, this is going to be my y component of my Coast Guard. Y of the Coast Guard. CG. Right. So now look at this. It's a nice little triangle. We just need to find the side of this, and then we can do the a squared plus b squared equals c squared thing, that whole Pythagorean theorem thing, and solve for this hypotenuse here. But first we need to find the x components of both of these vectors and the y components of both of those vectors. Same vectors I'm talking about here. So let's do it. Let's just set it up. Okay. It's going to look kind of like a grid. First I'm going to talk about, let's do the y components first. So since I'm already in the lavender. So for this y component right here, I'm going to do the sailboat first. So for the sailboat, that's how you spell sailboat. For the y component of the sailboat, right here, this is going to be, well, first of all, I got to figure out what all these trig identities are. So it's going to be our SOHCAHTOA. So, ka. Wow. To, right. So I'm going to focus right now on the so. So is the sine of any angle equals the opposite over the hypotenuse. So if you want to find the opposite side, all you do is multiply hypotenuse times the sine of that angle, and you'll find the opposite. So in this case, I want to find, it'll be this right here. We're finding this angle. Actually, you know what I'm going to do? I'm going to put this line over here too, so you can see it's a little bit easier to see. It's the same length. I'm just going to redraw it over here. So now I'm looking at this angle, this 36 degrees, and here's the hypotenuse of this right triangle here. It's a right triangle. This length is 20, so that's a hypotenuse. So I can write 20 times the sine of this angle, which is 36. And that'll give me this side right here, this y component. That's what I want. So that'll give me my y. So if I put this in the calculator, it spits out 11. I'm going to use extra sig figs here. This many kilometers. 11.7557. I'll round it later, but right now I'm just going to use a lot of extra sig figs. So that's a y component of our sailboat. Now let's do the y component of the Coast Guard. Coast Guard over here. The y component of our Coast Guard is going to use the same kind of function right here, except now our length for this hypotenuse of this triangle up over here, our length is going to be 35 kilometers. So it's going to be 35, and our angle now is 42 degrees. And this equals, what does this equal? This equals 23.4195 kilometers. So what I did right there is I found this length right here by taking the sine of this angle times this hypotenuse, and I got this opposite side right here. That's all I did. So now I've got both the y right there, which is this right over here of the sailboat, and I got the y right here, and that's this length right here. So if I add those two together, I'm going to get 35.1752 kilometers. And that's this entire length right here. So this whole length right here is 35.1752. All right, so now I'm going to do the same procedure, except for now I'm going to use this trig function right here for cos. I'm going to use cosine, and I'm going to use this right here, this little mnemonic. So cosine, and I'm going to use that orange again, the tangerine again. So for cosine, I might as well just do it like this. Cosine of any angle is the adjacent side over the hypotenuse. So if we want to find the adjacent side, we take the hypotenuse times cosine, and that's going to get us our adjacent. So let's do our x values over here. So we're finding the x components of these vectors now. So the sailboat, let's do this one right here. It's pretty easy. I did write it on this side, but I could also write it right here. It's the same length. Okay, so our sailboat right now, the x component right here is going to be the hypotenuse, which is 20 times the sine of 36, and that equals, what does that equal? That equals 16.1803 kilometers. And again, I'm going for lots of extra sig figs here. I don't want to round yet. And that x right here, this x that I just found, that sailboat, I'm going to add it to the x of the Coast Guard. And the x of the Coast Guard is going to be 35 times the cosine of 42 degrees. And that's going to get me 26.0101 kilometers if I round. And I'm leaving lots of extra sig figs here again. So I'm going to add these two together, and then it'll give me my whole length of this triangle right here on that side. And that's going to be 42.1904 kilometers. Right, so now I've got both of these lengths. I've got this length, and I've got the y length. So now all I need to do is treat these as the sides of this triangle and find this hypotenuse, since these are at right angles from each other. This is the y component, that's the x components. They're by definition 90 degrees from each other. So I'll do that. So this is going to be, I'll use a different color right now just to do this Pythagorean theorem. I'll use the color red. It's called maraschino, like the cherry. So it's a squared plus b squared equals c squared. So that means that the square root of a squared plus b squared will equal c. So I'll plug these numbers in, and what we get for c is a total distance, if you round it now to 2 sig figs, that's what I'm going to do, it's going to be 55 kilometers. So that is our length right here. Right here is 55 kilometers. 55 kilometers. So that's the distance separating these. So that's the answer. But now we want to find the angle as well. So I'll do the angle right here. So the angle I'll do in green. It's in spring green. So we want to know this angle right here. We could find that angle. We could find the other angle. We could find the angle right here, but I'm just going to choose inside here because it's a little bit easier. So to find that angle, you do another trig function. It's going to be the inverse tangent of the opposite of this angle. So it'll be the opposite of this angle, so it'll be